All right, I'm here to introduce our next speaker, Bipin Mistry, who's coming in from Carrero, and he's going to speak about the anatomy of multi-vector DDoS attacks.
So, good afternoon. I'm gonna talk about specifically about DDoS attacks and sort of the nature of them and how they are formatted and how they come in. I'm not going to go into areas around mitigation and things like that. That's a sort of a much broader and a separate topic in terms of how specific systems are set up to whether they do rate limiting or whether they do other heuristic techniques to mitigate. Quick background about myself. I run the product management organization for Carrero, which is a DDoS mitigation company. I'm not an engineer. I'll state that up front, but I used to be, so that's my excuse on this. And as I said, I'm going to talk about DDoS attacks in general, how they attack, how they appear, the sort of the mechanisms behind them. The screen is slightly out of whack now because the original presentation was in 16.9 and they had to drop it to 4.3. So that arrow and thing should be on real-time mitigation and not alerting and reporting. But what I want to do is talk about sort of the mechanisms that you should consider as you're thinking about when you're looking at DDoS in particular. Things like initial configuration, for example. One of the things that we find when we go into specific customers is that even though they're under attack, that there are basic things that they haven't done on their server side or in their firewalls or in their IPS systems and things like that, just to understand the nature of some of these attacks that are coming in. Before I go on through some of this, how many people have experienced a DDoS attack in the room? Right, so yeah, it's a common thing, right? And to be honest, they're getting worse. It's not the ones that get the most press are the ones that you may have heard about this morning, which is around the 300 gig attack or the 400 gig attack. Those are the things that get the most publicity around everything. What we find is that those occur on us not as often. Sometimes it's actually quite difficult to generate that size of attack. What we find are the ones that come in, say 10 gig and below, that last for hours on end, but are very low in terms of saturation attacks. They can cause the most damage. The other thing that most people assume about DDoS attacks is that they're actually there to take infrastructure down. Most DDoS attacks have started to evolve. They're not there to take infrastructure down, so they're not there to take your servers down or specific services down. What they do is they mask other attacks that come in behind the original DDoS attack. So what we found is that you get one or two attacks that are volumetric in nature or reflective in nature. They come in behind that specific attack. So while you're busy trying to work out exactly what those attacks are doing, the third attack that actually comes in is actually a brute force password attack. So it's actually attacking your server to try and pull information from the system itself. So those are the types of attacks that we see coming in. And the other thing is purely from an analytics and a logging perspective, you're busy looking at all the different logs that you're seeing in your firewalls, in your IPS systems, trying to understand exactly what the nature of that attack was. And what you're missing is the actual attack that the perpetrator wants to push through the system. We also see other mechanisms of attacks coming in now. So for example, most people are familiar with DNS attacks or using DNS as a mechanism to attack or NTP as a mechanism to attack. We've seen attacks coming in from gaming servers as well now. So a standard mechanism now, for example, is you connect into Xbox Live or PSN network. One of the things that you do is you get a list of all the servers that are available for a particular connection or a particular game. That is also a mechanism that people are now using to generate DDoS attacks. So you send in a request. The response that comes out is a huge list of servers. That can be then targeted to a spoof address, and that is a vector for a DDoS attack. So what we do is so other than initial configuration, monitoring, detection, ideally the ideal state is every DDoS attack you see coming in is automatically mitigated, right? That's the sort of the nirvana state for everything, right? You see an attack, whether you know the vector or not, it's automatically mitigated, and you then stop it. Then you've got alerting and reporting, forensic analysis, and then you have to circle back on this loop on a regular basis. So you start to change your configuration based on the nature of the attack that's coming in. So this is what I'm going to now do is walk through, and again, this slide was in 16.9, it's now flipped to 4.3, so it looks slightly odd. I'm going to walk through a specific attack. Now, on the surface, it was a single vector attack. It starts at something like 4 in this case, something like just after 4 o'clock in the afternoon. Something like 4:30, somewhere around there. And the whole attack lasted for about 12 hours, 12, 14 hours. It's a very long duration DDoS attack. Now, the key thing in all of this is if you look on the left-hand side of the screen and look at the link utilization itself. Again, as I said right at the beginning, most people assume DDoS attacks are typically 300 gig, 400 gig in nature, complete saturation attacks across all multiple links. This was only reached just below 2 gigs. Now, this specific attack, if it wasn't mitigated, would have caused massive damage on the firewalls that sit behind the infrastructure, along the networking equipment, on the IPS systems, any application load balancers that sit in front of the data centers, and then on the back end on those servers themselves. It's only, as I said, just below a 2 gig threshold in terms of attack. So this is the primary attack mechanism, and it came in at just after 4 o'clock and lasted about 14 hours. So it's a long duration attack. Other attacks that we see come in typically about 2 gigs in size, last for 30 minutes. Now, the problem with that type of attack is that if you're in the middle of a switchover, so you're switching across to a cloud-based provider, or you're looking at doing a scrubbing type reroute, you have a 30-minute window or a 2-minute window in terms of when the attack comes in and when they stop. The reason that they do this type of stuff is they're actually pinging and they're probing your network to understand what the response is coming back out of the network and see whether there are any gaps in the network. So they're actually scanning across your entire infrastructure, and they're sending in low-level attacks. What they're trying to work out is which servers are open, which ports are open, what is the susceptibility of your network to a specific attack. Once they've worked that out, then they go in and start launching bigger and bigger attacks into the system. And there are other things that go on inside in this sort of the specific security world, where, for example, gaming companies or gamers running on will take down other gamers just so they can get ahead of the queue and things like that. Those are primary attacks in that specific region. But what we've seen is lots of scanning and just to determine what the holes are in any particular network. They're looking for responses coming back. And if you're looking at sort of switching over into cloud-based environments, you won't be able to detect any of those attacks coming in. So you won't see what the initial nature was before the primary attack then launches into the system. So for that specific attack, in terms of what did we see in terms of sort of the variations from the norm? So if you just look at sort of things like the external packets per second that was coming in, it suddenly shot up. It was typically running at a lower rate. It went up by 49%. But the real key thing that I sort of want to home in on this specific thing was number of UDP flows that were coming into the environment. On a sort of, for this particular network and this particular customer environment, it was low. I mean, typically their average UDP rate and everything, or the flows through the system was pretty low. It suddenly shot up by about 500%. And there's a couple, I'm not going to read through all of these, but there's a couple of other areas that sort of were sort of interesting, and they were immediately sort of highlighted something was going on inside this network. Things like ICMP flows suddenly increased as well. So in terms of other vectors that were being targeted, the primary attack, as I said, was a UDP attack initially. Right? It was targeting port 53, which is DNS. And as I said, this is the sort of the simplest attack that we've seen coming into these types of environments. They're getting more and more complicated in terms of the way they come in. So this was a typical DNS type reflection attack coming in, lasted a fair period of time. What we see is not just single vector attacks, but 4 or 5 vector attacks coming in. And again, in terms of the PDU length size, sort of it changed from what it was traditionally running. So when we employ our systems, we run them for a period of time across the network. We get a fairly good baseline of what the particular traffic profile is across that system as well. And in terms of the source and destination IP addresses, we saw a range of addresses coming in as well. Typically, we don't see this unless there's something anomalous happening within that network. So in terms of an engagement, the moment that we saw the attack coming in, and sort of the moment that the system started to mitigate or started to detect and mitigate happens in a very short period of time. And again, this is key in terms of not when you're looking at when you're seeing sort of high frequency or high capacity saturation attacks, but it's actually really important when you see low duration, low frequency attacks that are very short in time span. You have to initiate and engage them in very short period of time, otherwise they'll fly straight through your system and fly straight through the defenses that you have set up. So in terms of the initial analysis of this particular environment, again, it was a DNS attack. It was using UDP. The initial attack lasted 90 minutes. So the first attack that came in through the system on the original graph that I showed was a 90-minute attack, okay? And that was the initial kickoff of all the other vectors that started to appear behind it. So, and I've sort of hidden, 192, obviously, so I've masked out the actual IP address of the customer that was under attack. And it was a spray, so it was a destination IP spray across a number of different servers. So not only were they attacking specific servers, they were also trying to work out what was available on the other side of the network, on the other side of your security perimeter that you've set up. And each destination IP address was receiving, for example, about 0.5 in terms of percentage of traffic. So all they were doing was saying, targeting each specific address to work out what was there and what could they attack and what was open. So that's all this was an initial attack to see if there's anything coming back and whether I could take anything down. Subsequent to that, and in terms of the packet sizes, again, as I said, this was very easy to generate for the attacker, for the guys generating a DDoS. It was a small packet size, it was about 260 bytes. It was a spray of addresses across the network, and it was less than 2 gigs. So that was the nature of the primary attack. Right? That is not a very difficult attack to generate, and you just have to compromise a number of different systems and start initiating that type of attack. The harder attacks to generate are the multi-gig, the 300 gig, 400 gig attacks. They're not that easy to generate, but once you get going, people can do them now. This used to be sort of a black art in terms of generating DDoS attacks. It actually isn't anymore. There are all sorts of mechanisms on the web, and I was just reading one this morning, where they can tell you exactly, they'll walk you through and they'll step you through exactly how to generate attack. So this type of attack is very easy to do. It's low packet rate, it's low sort of in terms of actual capacity, bandwidth of capacity, and the key around all of this was the spreading of the attack across the system itself. The other tools that we use in terms of, so this is just a straight packet capture of what was going on. In terms of what the attack nature was, what we saw as the attack came in, the target attack that it was going after. After this attack, the secondary attack that came in was a TCP flood attack. So what they did was once they'd worked out what was available on the network, what resources were available, what they could primarily attack, they changed their attack vector. So they looked at exactly what was coming back from the system itself, and then they dropped into a TCP flood. Now that we have other vectors that I could show later on, which would basically they're going with a primary attack, they drop to a TCP flood attack, and then they'll go into another attack. Right? What they also do is work out the thresholds of your systems. So all the defenses that have been put into the network, they work out what those threshold values are. So you may have particular threshold values for your specific systems that say, start to rate limit once it hits this number. They work out exactly what those rate limits are, and then they start to drop in underneath that. And it's still a damaging attack because it could be a 500 meg attack attacking a particular service or attacking a particular server. As soon as it hits that server, it starts to take that service down. So again, the nature of a lot of DDoS attacks now isn't to just to take away services. Original thing was around, that's why it was called denial of service. It was to deny a particular service. Now it's actually to take data away from the system. So either a password attack or something to extract data from your system, which is important to the company. And that's the nature of why they're doing some of this stuff. For example, the attack on Sony was just before Christmas was to take down the PSN infrastructure. Right? So they sold a bunch of new games. They took down Sony. No one could attach for those games anymore. And the same thing happened with Xbox. So some of it is to do with data, just to pull data from the system. Other things is to take services down. It's a combination of things that is going on. So in terms of the secondary attack that started to occur, that was targeted at a specific set of clusters. So initially, it was the original attack was spread across a set of destination IP addresses and a set of destination ports. The secondary attack was a TCP flood, and it was targeted at a specific set of servers. They knew exactly what was there. They knew what they wanted to attack, and they started to hit those specific set of servers. So they did the original thing just to work out what was there. The secondary one went in to actually target something. And again, you can just see by the variation in terms of data what was going on, or what, from our perspective, in terms of what the average rate was and what the explosion in traffic rate was over a 15-minute window as this was going on. In terms of things like TCP flags, in terms of source ports, etc., we saw a huge spike in certain amounts of traffic going into the system as well. So those particular target servers that they were attacking. In terms of the PDU length size, we saw an increase in terms of what the actual traffic patterns were. So again, the original attack was to target with low packet values, just do a scan of the network. The secondary one is much more targeted in terms of what they were trying to achieve. So finally, the actual attack looked like this. The first segment of the attack was a UDP attack vector. It came in around 4 p.m. in the evening, and it was about just under 2 gig in terms of worth of traffic, and it lasted probably about 9 hours or so. At that moment, what they did was once they'd done their initial scan, they switched to a TCP attack vector straight after that. And that lasted the remaining period of time. So it's a matter of what they were seeing inside the network and then how they could switch. What we've seen is attack vectors that go from UDP to TCP, then they'll target specific applications like SSTP, for example. If you look at any particular application out there, there are specific applications that can be used to amplify a particular attack. So DNS is the obvious one. NTP can be used to amplify a particular attack. So when you send in a request, it will generate a huge packet. If you compromise enough NTP servers, you'll get a huge attack. On the back of some of these, SSDP is another mechanism that you can now use. We've seen that quite often where they will compromise UPnP, for example, as the protocol, and they will start to target and use that as an amplification attack coming into the system. So the key thing around all of this is that DDoS attacks are increasing. And there was a presentation this morning about BGP flow spec as well. What we found is that it's not necessarily the size of the attack that's coming in, it's actually what the attacker is trying to achieve. That's the real, sort of the real point around some of this stuff that we're seeing now. So that's all I have from a presentation perspective. Is there any questions? Okay.